All right, in the process of simplifying a distance equation, I can take a look at the way in which things fly. Now, if I have a pumpkin here and it is shot out of a cannon, it follows this path called a parabola. And I can break its velocity up into two components at every single point in the flight. So initially, the pumpkin is traveling at a very high velocity in the up direction and a very high velocity in the right direction. But then, if I pay attention to its velocity a little time later, the velocity starts to decrease, and this is due to gravity. Now, to be honest, scientists have established that the rate at which it decelerates is negative 9.8 meters per second squared. But in the x-axis, scientists have found that the velocity does not change that much. It continues at the same rate in the right direction as it always had. And Newton came up with a law that explained this, and it's called Newton's first law. It's called the law of inertia. And what it states is an object, including pumpkins, in motion, tends to stay in motion unless acted upon by an outside force. So once we get the pumpkin moving towards the right at a particular velocity, that velocity doesn't change that much. If that is the case, we can say that the acceleration in the x-axis equals 0 meters per second squared. And once again, that's due to Newton's first law of inertia. In order to simplify the distance formula on the y-axis, I can take something about the acceleration due to gravity, which is on the y-axis, is negative 9.8 meters per second squared. In order to simplify this formula, I can distance in the y-axis equals velocity initial in the y-axis times time plus 1/2 whatever the acceleration is, and in this case it's negative 9.8 times the quantity t squared. Now if I were to simplify this portion of the equation, I would get negative 4.9, and then when I fill in the rest of the details, I get my simplified equation.